Okay, I've got a member here that's got a pin at A and a cable BC, and it's loaded up with 300-pound weight as shown at D. Okay, and I want to find the X, Y, Z components of pin A and figure out that tension in the cable. So we'll start with the free body diagram, which I'll draw right on top of the body here. So again, I've got 300 pounds acting straight down. That's in pounds, so I don't need to convert it with gravity or anything. It's already given as a force. I've got my tension over here at B, which we'll go through and write the Cartesian form of in a second. And then I've got some stuff going on at A. So again, what we're looking for is what I can't do. And because of the pin, I can't move in the X direction, cannot move in the Y direction, and I cannot move in the Z direction either. Okay, so that means I've got an AX, an AY, and an AZ component at that pin joint because I can't move linearly in any direction. Now, what I can do is I can rotate about the x-axis, okay? Uh, so there is no reaction about the x-axis, no reaction moment. However, if I try to twist that or rotate it about the y or the z-axis, that pin joint restricts that motion. So there would be a reaction moment about the z-axis um, as well as about the y-axis. So we'll go ahead and draw in there the moment about the z, moment about the y. Again, not one about the x-axis because it's free to move. It's free to rotate around that axis, so there's no reaction moment there. So before I go ahead and get into my equilibrium equations, the first thing I'm going to do is go ahead and draw my, not draw, write my tension in uh, Cartesian form. So that's an unknown tension, but I need the unit vector, so that's the position vector over its magnitude. So going from B to C, I go 3 in the I direction. I go 9 minus 6 in the J direction, and then I go up 2 in the K direction. Now, we've seen this before. It's a 2, 3, 6, 7 sort of situation here. So the magnitude square root of the sum of the squares will be 7. Okay, so that gives me that. So now that I've got this, I'm going to go ahead and deal with my reaction forces. I'm sorry, not my reaction forces. I'm going to sum my forces in the x direction. So I've got my reaction AX there, and then I've got this tension, right, which is 3/7 times the tension in the x direction. That's all I've got going on in the x direction, so I set that equal to 0. Similarly, in the y direction, I've got AY, and I've got minus 6/7 times t, and that's all I've got in the y direction. Now in the z direction, I have the z, AZ. I also have the 2/7 t, okay? But I also have the 300 acting straight down. That's that weight that I've got applied there. So I'm going to go ahead and include that. Now, these are 3 equations, right? But I've got 4 unknowns, AX, AY, AZ, and T. So I'm going to need more equations. Fortunately, I have moment equations. Unfortunately, those moment equations are in 3 dimensions, which make life a little challenging. So what I'm going to do is I'm going to do some cross products and then pull out the X, Y, and Z components of that moment equation. So I'm going to do this moment about point A because AX, AY, AZ will then disappear, right? They do not create any moment about point A because they're at point A. We usually choose a point with the most unknowns at it, which obviously is point A here. So I do that. I want to include any couple moments, and a lot of people forget these, so don't do that. Okay, I've got my reaction moment, AY, and um, reaction moment at A about the z-axis. So you want to make sure you include those. Those are the 2 couple moments that I've got. Now I've got a couple of R cross Fs that I'm going to deal with, right? So we'll start with the 300, right? So to go from A to that D force, I move -2 in the X, and I move 6 in the Y. And I'm going to take that and I'm going to cross it with the -300 in the K direction. Now I'll do the same thing going to B, okay, where this time I'm going to go -4 in the X, and then 6 in the Y, like so. And then I'm going to cross that with that tension force that I've got there, which is again is the 3/7 t in the I direction, the 6/7 t in the j direction, and then the 2/7 t in the k direction. So doing these two cross products, I have this cross product here, which if I do that, I get minus 1800i plus, I'm sorry, minus 600j. Okay, so I'll let you do those cross products and prove that to yourself on your own. My t cross product with the tension that I've got here will become 12/7 t in the I direction plus 8/7 t in the j direction plus 6/7 t in the k direction. Okay, so now I've got all of my moments. I did it, did those cross products, kept them in 3 dimensions, and then I am now going to break them up into my x, y, and z components. So in the x component, okay, I have minus 1800. I've got that I component. And then I've got the plus 12/7 t. So that equals 0. Now I do the same thing with my j components, okay, where I have MAY, right, the reaction moment in the y direction. I've got minus 600, and I've got plus 8/7 t. Those are my j components that I have in the moment equations. And then I do the same thing with the z components, okay? So I have MAZ, nothing from the 300 about the z-axis, okay? And then just plus 6/7 t equals 0. So here's the thing now. Now I've got 6 equations and up to 6 unknowns, right? A, X, Y, Z, M, A, Y, M, A, Z, right? I've got those 5 reaction forces and then the tension. So I could solve all of these. Now, all I'm really looking for here is the tension, which I can solve from this equation right here. That gives me a tension of 1050 pounds, solving that equation. And then once I have that tension, again, all it's looking for is the XYZ components of the reaction it pins. So it's basically AX, AY, and AZ, which I can get right here. And I get, well, I don't have those. So I'll let you do those on your own and we'll just stop it right here. So again, with this, you draw a free body diagram. Any three-dimensional forces you probably want to get in Cartesian form. Then go ahead and sum the forces in X, Y, Z, set them equal to 0. Then take a moment about the point with the most unknowns, do all of those cross products, and then pull out your X, Y, Z components. That way it makes it easier for you not to forget a specific moment. At that point, you'll have 6 equations and you can solve up to 6 unknowns. Again, I just solved for T here, but once you know T, you can easily plug it into every other equation, find every other reaction force that you may need.